Definition of trig function for any angle. So we've been looking at the right triangle trig, and it's a something that people are more familiar with. The issue with right triangle trig is that you have some limitations, and the first one is um, you can't do anything bigger than 90 degrees, right? Because if you have a triangle, you can have one 90-degree triangle, and the other two angles are going to be less than 90. So there's really no way to make this work when the angle is larger and still a right triangle. I mean, you can have triangles with bigger angles, but not a right triangle. And so we need a different way to look at it, a different format. So we're going to look at finding trig functions, okay, using the ratios, but we're going to have a different definition because we're going to look at it from a different perspective. Okay. You'll see the similarities here. All right, so we're going to find the sine, cosine, and tangent for an angle created going through the point 3, 4. So what I'm going to do is I'm going to plot the point 3, 4 on a coordinate plane, and then I'm going to draw a line from the origin from 0, 0 through that point. And that's what I got right there. So if you look at this, the angle that I'm going to do is created from the x-axis to the radius, or that's the line that's created going through that point. So it's that angle underneath it in between the x-axis right there. So to find the sine, cosine, and tangent, I still need a triangle. So I'm going to draw a triangle in from that point, and I got to have a 90-degree angle. So when I do that, I'm going to have my 90 down here. I'm going to have my 90 down here. Okay? And what we're going to do is figure out the length of the side. So we can get these legs here, right? Because you can see this is my hypotenuse, right? It's opposite the 90. And I know how to plot a point. I went to the right 3 spaces and up 4 spaces. So I'm going to go ahead and just put that on there. So the thing is, to find the trig function, I need to know all 3 sides. And since I drew in a right triangle, I'm going to use Pythagorean theorem to figure out that third missing side. Now, because it's on the coordinate plane and I drew it through, I'm going to call it a radius and not hypotenuse. That's why I'm using r, right? And a squared plus b squared equals c squared. So we're using r instead of c, or h for hypotenuse, but it really is the same thing. So 3 squared plus 4 squared, right? Square those out and I get 25. Take the square root of both sides, right? Take the square root of both sides, and r equals 5. So that's the radius, right, or the hypotenuse of the triangle that I just drew. Okay. So here is where you need to write down the additional definition. Okay. So it's going to be that we're going to define the sine, right? And the other definition we had was opposite over hypotenuse. We're going to define it as the y value divided by the r value. So remember, the angle that I'm using is this angle down here in the corner here by the origin. So 4 is the opposite side, and 5 is the hypotenuse. But since it's on the coordinate plane, we're going to say y over r, the y value divided by the radius. So I put that in, I get 4 over 5. And you can hopefully see the similarities to our right triangle trig definition. The cosine is defined as the x value. In this case, it would be the adjacent side divided by the radius. All right, so that's 3 over 5. And then I'm going to do the tangent equals y over x. Okay. So it's going to be, if I'm down here, it's going to be the opposite side over the x, and we get 4 over 3. Okay. So if I ask you, so from here on out, the vast majority of the time, we're going to use this definition. So I'm asking for the definition of sine. I want you to start saying y over r, not opposite over hypotenuse, as a much more limited application. Just for this question here, let's look at the reciprocal functions, cosecant, secant, and cotangent. So I put the same diagram. There's a Pythagorean theorem again, but this time these are the reciprocals, right? So remember, cosecant is the reciprocal of sine. So instead of y divided by r, it's r divided by y. So the y value goes on the bottom this time. And the secant of theta is the r value divided by the x value. All right, 5 over 3. And then the cotangent is the adjacent side divided by the opposite side. But in this case, we're going to say the x value divided by the y value, or the sides of the triangle. and that is our cotangent. All right. So let's just look for the main three reciprocal or functions in some other quadrants. So this is where things get different. Okay. So find the sine, cosine, and tangent for an angle created by going through the point -5, -4. Okay. So looking at something like this, what I'm going to do here is um, I'm still going to draw in that triangle, right? But -4, -5 is in the third quadrant, right? So when I label the sides of my triangle, it's 5 spaces, but it's really going to be -5 because that's the direction of the side. So it's not just the distance. The negative and positives matter on the XY axis. So now when I want to find that missing side, I need to do Pythagorean theorem again. So it's going to be -4 squared plus 5 squared equals r squared, right? So I'm going to get the square root of 41. Okay, take the square root of both sides. All right, so now I can label that hypotenuse. So now I know all three sides. I want an exact answer, so I'm not going to get a decimal. I'm going to leave it as the square root of 41. So now I'm going to go ahead and find the sine. So remember, the definition is the y value. So the y value is the vertical distance. So it's -4, and the hypotenuse, or in this case, the radius, is root 41. Now, what's different about this compared to what we do with right triangle trig is that we got a negative sine value. That wasn't happening with right triangle trig. You don't get negative sines, cosines, and tangents. But when you go bigger and you go in these different directions, you do. So that's why we end that. And if I rationalize it, that's what I get. Cosine is the x value. In this case, the x value is -5. Right? And same thing, I'm going to have to multiply it by root 4 over root 4. And there's my rationalized answer. Tangent is the y value divided by the x value. So the y value is -4, and the x value is -5. So these are going to be a negative divided by a negative is a positive, right? So that's going to be a positive tangent. So now the main difference is that we're going to have these negatives and positives in the sine, cosines, and tangents that we otherwise never would have had with just right triangle trig. All right, so now we're going to go through the point -5, 2. Okay, so that puts us in quadrant 2. So just keep in mind the x's are negative and the y's are positive in this case. So draw my triangle, label what I know, right? Label what I know. I got -5 squared plus 2 squared equals r squared. Okay. I'll do 25 plus 4 is 29, and I will get a radical that's not going to simplify again. I'll get the square root of 29. So in this case, I'm going to go and label um, my radius, right? We're going to use the term radius, not hypotenuse, okay? And the sine is the y value. The y is the vertical distance, so that's 2 over root 29. Rationalize that. Cosine is the x value, which is -5, right, over the r value. So we get -5 root 29 over 29. Then lastly, the tangent, is the y value divided by the x value, which is 2 over -5. Okay, and I'll probably just put that negative sign out in the front. That is going to matter down the road, though. All right, so same thing, but we're going to go through the point 2, -4. Okay, so now we're in quadrant 4. In this case, the x's are positive and the y's are negative. That stuff's going to be real important here pretty soon. So drawing a right triangle, right, that ends at that point. Label what I know. I went to the right 2, positive, and down 4. Let's go ahead and do my Pythagorean theorem. It's going to be 16 plus 4 equals r squared. 20, take the square root of 20, right? Okay. So now what we're going to do is we're going to go ahead and put this into the formula. So the sine is defined as the y value divided by the r value. So it's going to be -4 over 20. Okay. So I'm going to rationalize that and multiply by root 20 over root 20. And this one actually simplifies. I had another video you guys should have watched before this, how to simplify that. But that's where you end up. Cosine is the x value, which in this case is 2 divided by 20, root 20. Rationalize it, then simplify it. And everything's going to simplify down to root 5 over 5. And lastly, the tangent is the y value divided by the x value, right? Negative 4 over 2. That reduces just negative 2.